Now let us discuss about the relative position of image formed by a convex lens. Here there are various cases we are going to study about different positions of object and corresponding image produced by a convex lens. So if we consider case 1, object is at infinity. And we know if object is at infinity, incident rays on the lens would be parallel. So here if we just have a look on the situation, if there is a convex lens on which parallel incident rays are falling, we know that after refraction through the two surfaces of lens, the image will be produced at the focus because all the refracted rays converge at the focus point. Now in the similar situation, we can see if incident rays are parallel, object is at infinity but not along the principal axis, and say if all incident rays are falling at some angle to the principal axis, all the rays will converge in focal plane and image will be produced in focal plane. So here we can see image is formed in focal plane, and about the image we can write it is real and diminished also. And we can see if the object is real, then the image produced will also be real, so it will be inverted. Now if we talk about the case 2, we can see if object is placed beyond 2f point, like the situation we can see in this analysis where on the left side of the convex lens an object is placed beyond 2f point. So the light rays which are falling onto the lens here, we can consider one ray is passing through the optic center of the lens and another one is parallel to principal axis. So after refraction, according to the rules we have studied, you can see the image produced will be between f and 2f. So here we can write image is formed between f and 2f, and about the image here we can write it is real, diminished, and as a real image of real object is produced, it is also inverted. If we talk about case 3, where we can say if O is placed at 2f point, then in this situation we can see if we consider two rays incident on the lens from the object tip. So here the ray which is passing through optic center will move undeviated and the one which is parallel to the principal axis will pass through focus, and you can see symmetrically it produces an image at the 2f point only. So here we can write I is formed at 2f, and we can say this is real because refracted rays are converging and it is of same size. By geometry it can be easily verified, and as real image of real object is produced, it is inverted. Let's continue with more cases on the next sheet. Let's continue with the case 4, where we can see if object is placed between f and 2f. So here you can see in the situation on the left side of the convex lens, the object is placed between f and 2f, and again if we consider two rays according to the rule, we can see that here image is produced beyond 2f point, and as converging refracted rays are there, so image will be real, and here we can see it is enlarged, and again real object is producing a real image, so this will be inverted. Now if we consider case 5, in which we see if O is placed at focal point, Then here in this situation we can see the light rays which are originating from the object, the incident light rays in various manner after refraction are getting parallel to each other. So here we can see that image is formed at infinity because parallel rays will meet only at infinity, or we already studied whenever refracted rays are parallel we say image is formed at infinity, and in this situation we cannot define the nature of image. So here we'll simply write in this situation I is formed at infinity and it is highly enlarged because it is located far away from the lens. And the last case we can see, in the sixth case, if O is placed between the focal point and pole of the lens or the optic center of the lens, then in this situation here you can see, if we consider a ray which is incident on the optic center, it will pass undeviated, and the ray which will be incident parallel to it will be passing through the focal point, the secondary focus of the lens. So in this situation the refracted rays are diverging. So on back extension these are meeting out at a point on the same side of lens where object is placed, and you can see the image produced will be virtual. So here we can write I is produced on same side of object, and here we can write it is virtual, enlarged, and as real object is producing a virtual image, here we can write it is erected. So this is the way how we define the relative positions of images produced by a convex lens for a real object placed at various positions.